All right, so we're doing our first webinar here, and I wanted to welcome you here to this first webinar on how to convert assets using RapidPipeline in 3ds Max for web and XR use. I want to let you know my name is Eric Chadwick, and I'm Senior 3D Technical Artist here at DGG, and I'm a workflow specialist, so I help our clients figure out how they can get their 3D processing jobs done. And I've got tons of experience in 3ds Max. And I want to show you how we can get assets out to web and XR ready in just one click. It's super easy to do. So feel free to drop any questions that you might have in the QA section, and we'll spend some time at the end to go through them and talk through any things that you have. So a bit about RapidPipeline. What we have is this great customized tool set that you can automate the 3D data preparation of your 3D assets and optimize them for a bunch of different use cases. And it just makes it a lot faster and easier to publish 3D assets on the web when you can automatically basically optimize them down to something that works for your customers and loads fast and renders great. So what our session covers today is we're going to talk about how to do 3D optimization directly inside of Max and how to export your assets directly to a clean and a lightweight file. And we have a whole bunch of great import assets as well. So you can import all kinds of CAD formats and 3D formats. We'll talk through that. And it just saves a lot of time because you're able to leverage these really smart tools to optimize your assets quickly and efficiently. So let's jump into it. Let me pull up 3ds Max here and show you the RapidPipeline tool. Basically installs as a plugin, runs directly inside of Max. And we have all these great tool sets for it. We have a whole bunch of actions that you can perform on your assets, but to actually get assets in, you can import your files directly. And what we have is the ability to import a ton of great formats here. So it's not even going to show here because it's such a huge list. But basically, these are all the formats that we support. And you can import all of these files. And what's really useful here is that there are a ton of CAD formats here. So all the common formats that you have to deal with in CAD, and you need to tessellate those to make those into real-time files that you can show on the web. And you need to optimize them often because they're super complex and rich. I think for the first assets, let's just choose one that's a common like e-commerce asset. And that's this shoe asset that you can see here in the animated GIF. So when you import a 3D file, you get a bunch of options. You get CAD options for CAD files, and you get 3D format options for other 3D files like this GLB file. And there are a bunch of great options here. If you know that the asset's coming, for example, it's an FBX file coming from Maya, and it's Y up there, then you can convert it between that into the Z up that's used in Max. There's also some USD options so that you can pull in display colors and other things. You can discard a bunch of things if you don't want those. It's all really helpful to give you options about how to pull things in. So I'm just going to choose the defaults here and import it directly in. And what's happening is the GLB is going out to our custom executable that runs in the background that has all the code to do all the optimization and import. And then we're importing it as an FBX directly into Max to preserve all the materials and the geometry from the original file. So that way you're pulling in something that actually Max supports in all of its formats and glory. And so what's happened here now is we've imported this asset, and it originally came from Sketchfab. So it's got the original nodes that were used in Sketchfab, as well as the original meshes and how they were named. Plus what we've got is our own node on top as the parent. And what this does is organize your scene so that when you're optimizing this asset and adjusting things, you can actually go back to previous versions. It saves all those versions here in your scene hierarchy. So now that we pulled this asset in, we can look at it and see that it's made of, let's see, if we get rid of these dummy objects, we can see just how many meshes there are. There are these 6 meshes, and it's 145K triangles. And if we pull up the material editor and grab all the materials from the scene, we can see there's 4 materials here. I'm going to collapse them so they're easier to see. So there's 4 different materials here and 6 objects. And generally for the web, for a single item like this, I'm going to want to collapse it down into one material and one mesh node. And that makes it super efficient, makes it one draw call, super fast. It runs really well in AR, and it'd be super efficient. Now, actually, converting this down in general is not super easy in Max itself, right? You'd have to attach things together and adjust sub-object materials and then bake it all down to a single atlas, generate a UV, all those fun things. And what happens here in our actions is you can do all that in one click. It's all right here. So you can choose the resolution that you want to bake the atlas to. I'm turning on a bake occlusion map option here because the original doesn't have occlusion maps in it. And ambient occlusion really adds to the PBR look. And there's a bunch of other options. So I'm going to choose a face target. This is already set to 20K. That's great. I think that's going to be a great target for us to get this file size down really low. And then the other thing we can set here is set how the merging happens between the meshes and materials. And there's a bunch of different options here. So if I had a bunch of objects that, say each of the laces were an individual object, but they all shared the same material, I could merge them all by material. So it would merge all these laces into one object because they all share the same material. Now I know already that this asset doesn't do that. It has just one object for all those laces. So I don't really need to do that. But what I want to do is actually do a full merge. So basically take all the assets in here, all 6 assets, and merge them into one asset and bake a new ambient occlusion and a new atlas. So I'm going to go ahead and run this. And what's going to happen is in the background, make sure WebRoot's not stopping it with its firewall, but I think it's running fine. So what happens is that it exports it as an FBX file, loads it in the executable, the RapidPipeline core file, does all the processing there, and then re-imports the file back into 3ds Max. And what's notable here is that executable is basically running locally on your machine. No data goes out to the web. This is totally private to me. And this file isn't shared with RapidPipeline at all. It's all runs totally locally. So that's great. And if you have proprietary assets and you don't want to share them on the web and keep them all local and native. So it finished the processing and pulled in the changed file. And here it is at 20K. And it's a single item. So here's a single mesh node, and you can see the topology there. It's preserved all the curvature, but gotten us down to 20K. So let's export this now to a web-ready file. And what I'm going to choose here in the export dialog is you've got a few different options to go out to USDZ, etc. I'm going to choose a GLB because there's a lot of great web viewers that support that. So I'm going to call this shoe new and save it. And when I do that, I get some export options. Now this is really helpful. If I want to choose some geometry compression for it, say I have a CAD model with a lot of data, I want to make it really small. It might be helpful to use geometry compression. And you can choose different levels of compression here. For this asset, it's only 20K. I don't really need that. But what's going to help here is to choose some kind of compression for the images, for the textures that were baked. And I'm going to choose WebP because I know WebP goes out really small, but still preserves all the visual look. You can also set the texture resolution. So I baked at 2K, but you can set it here to a lower version. So say if I wanted to go out to 1024, I could do that. I'm going to keep it at the original because that was the image that I chose. But you can also do other things with the file. I'm going to go ahead and export this out. And again, it goes out to the executable, grabs the file, and it saves it. And let's go ahead and pull up that file that we went out to. Here it is. It's down from 30K on the input down to 3K on the output. So let's pull up a web viewer and actually get out to, let's see, not here, but if we go to desktop, and let's go up to pull up a web viewer, and we'll pull up the GLTF sample viewer and drag it in. And now we can see the asset in a web viewer, and it's basically down to a single mesh. So if you go to advanced controls here, you can see it's one mesh. It's down below 20K. And it's basically one draw call, super efficient. Another tool that we can use to look at files is to choose GLTF report from Don McCurdy, which is a really great tool for looking at GLTF files and seeing all the ingredients inside. So one thing you can do is you can pull up the textures here and see, yep, these are WebP files. They're at 2K. Here's the color map, the normal map, the metallic roughness texture, and the occlusion texture. And actually, these two, I think, are packed. Oh, no, they're separate. So they're separate as two separate files. And there it is. Now we've got the file in, and it looks great. So let's try a different file. Let's try one that's, say, a CAD asset. If we reload the file here, so we get an empty scene, and let's try to import a CAD file. We can talk through some of those options. So what I have here is this medical step file that's 55K. And when I pull in a CAD file, you can choose how fine to tessellate this file, which basically what happens is a CAD model is made of parametric surfaces, and they're not necessarily tessellated in the CAD file itself. But when you need it for real-time use, you need to tessellate it down to triangles. And we can choose different levels of detail to add to this. I'm going to choose fine just by default because that is going to give me the most detail in the file, and I can decimate that later down into something that works. And that way I'm leveraging the power of RapidPipeline to choose which parts to pull out and which not to. There's a bunch of other options here for fixing various things, but I'm just going to go ahead and import it. And so what's happening now is that step file is being loaded in the executable in the background, and it's being processed. And each of those parametric surfaces are having triangles added to them. And it's fixing various surface issues with the file, depending on which options you choose when you import. And so here it's by default, it's sewing the different parametric surfaces together that are near each other. So that way things become single surfaces wherever possible. So here's the files in, and it's all tessellated, and we can look at the wireframe. And this is what this asset is. It's some kind of medical pump thing that stirs together things. Actually, we can use the near clip to look through the object and see it has all these internal structures and things going on inside of it that we probably don't need all this internal stuff. If we can't see it from the outside and we're using it in a web viewer, we probably want to get rid of a lot of internal parts just to make it faster and easier to load and make it more efficient in terms of the number of vertices. So one of the cool things we have in the tool here is a remove occluded parts tool that basically goes in, and you can see the animated GIF here. It basically removes these hidden interior parts, but it's also smart about transparency in the surface. So for example, this microwave has a clear window on the front that you can see, and there's a slice of pizza in there on a plate. And the culling is smart about surfaces that have transparency. It won't cull things that are hidden, that are inside the object, but are behind glass. You can tell it to ignore that. Hey, if I don't care about the pizza and I just remove all the interior parts, then that's what that'll do. Now, I don't think this guy has any transparency. It doesn't seem like it's got those kinds of surfaces. So whatever, I'll just leave it. But you can also choose how fast you want it to go ahead and cull all those things. I'm just going to use the defaults here. And you can also set per mesh whether it handles the visibility per mesh. So for example, if I choose a mesh here and I isolate it and hide everything else and see this thing doesn't really work in this case because all the surfaces can be seen from the outside. But if there were internal structures inside of this thing, then per mesh would basically only look at those for each item and remove them from each item. Whereas with per mesh off, it looks at the whole mesh and decides, oh, parts of this occlude other parts and they should be taken out. So that's super helpful. And then visibility per part will look at how to remove the parts that it finds. For example, if it looks inside of this mesh thing down here, inside of this engine, it'll try to remove whole parts. in visibility per part and basically work on the element level of meshes and remove full elements. If you turn this off, it'll go on a per triangle basis and it'll cull individual triangles that it finds that are not visible from the outside. So generally, as a 3D artist, I don't like having a bunch of floating triangles inside of my models. It just looks really weird. I'd rather have it cull out whole parts. So I'm going to go ahead and run this. It's all the defaults, and it's going to go ahead and do all the visibility calculations. And there's returned a new file. And there it is. It's got the file, and it's removed the parts. And we've reduced the triangle count here significantly from the original, which actually let's see, if we select just the visible parts, I unhid everything. But basically, you can trust me, it removed a bunch of stuff. I'm going to go ahead and, we can do it this way. We can say select child nodes, and then we're going to hide selected. And then we can select all. And it'll show the triangle count, right? Control A. Yeah, anyway. So anyway, it did its job. But what we're going to do now is export this out to something that works in the web. So let's select the child nodes. And what I'm going to do is, again, decimate and bake atlas, because this is really useful for getting down to a good triangle count. The other thing that's going to do here is for a CAD asset, if this is 800K and it's got a lot of detail, I'm going to choose something that's more reasonable for a detailed CAD model and choose something like, say, 200,000 triangles. And that gets it down to a quarter of what it was before. I'm going to choose a little bit higher texture resolution because there's so much detail in this model. And when I bake the occlusion map, I'm probably going to need that extra detail. I'm still going to collapse it down to a full. One thing you can do too is in this particular asset, there are a ton of materials in this scene. So I'm going to say that, and there are a ton of objects. There are like 386 entities. And I know that there are 22 materials in this scene. That'll bake it down to 22 objects, which means then by material, each of those objects are visible. So let's try that and just see how that works. So again, what's doing is it's exporting this result out to an intermediary file, going out to the executable, and then doing all those calculations to collapse it all down by material. So all those parts are now 22 parts instead of 386 parts. Actually, it says 33, so there might be 33 materials. And then it's baking them all down together into a single atlas for all those 33 meshes. And then creating ambient occlusion, baking the color, baking the normal map. So it actually bakes a normal map from the high-res mesh down to the low-res mesh, which is super helpful too, because you're preserving that extra detail. And it's baking it all down at 4K. Another thing that's really cool is that we've got remove small parts as an option too. For example, if you have a bunch of tiny screws inside your object, and you know you're not going to really need those, then it's great to just remove all those tiny parts because they're just not necessary. So here it's done the work, and it's going to re-import it and show the finished result. And we'll be able to see what the file is. And it's automatically hidden the previous ones and shows the final result. And here we're down to 33 objects, 200K triangles. So let's export this again, export this out to a GLB file so we can load it. So I'm going to call it mesh pump GLB. And we get some options again. How we don't want to compress this. Let's try Draco. Why not? And let's choose just auto. What auto does is it says, hey, just use the default texture methods for GLB files, which are JPEGs for most textures, and PNG if there's alpha in the texture. I know this doesn't have any alpha, so it's just going to do JPEG by default. And the same for the normal map. And you can do other things. I'm going to pass on all that and just export it. And there it goes out. and it saved our file. There's our mesh pump. So when we look at it, the original was 55K. The mesh pump is down to 14K. So let's pull up the web viewer and let's drag it in and take a look. And there it is. And now it's got ambient occlusion, which is super nice. Whereas before it didn't have that. It was really cool. And it's preserved all this detail in the file. We've got all those fine parts are still there. And we've got ambient occlusion, which basically gives us a lot more kind of PBR material kind of beautiness, right? Let's pull into the sample view and we can look at the individual channels. So let's see what else. We'll see how many meshes it has, right? If it's a 14 megabyte file, I think we said it's 33 meshes. Looks like it's, yeah, there we go. So it's 33 meshes. It's exactly 200K triangles. And we can look at the debug views to see, hey, what does the occlusion look like? And one nice thing about RapidPipeline is you get really high quality ambient occlusion, and it's probably one of the fastest occlusion bakers I've seen out there, which is super nice. But it just makes PBR look that much better when you have occlusion baking that indirect bounce lighting so that you don't get super bright surfaces all over. And that's basically the demo. It works great in 3ds Max. You have all these options, ways to do different things within your file, and it's all logically laid out. You've got import and you've got export. Super helpful. And then the other thing I should mention is we have a great documentation for all the stuff that happens inside of it. So for example, each of these actions is documented in here. So you can look at what these individual options actually do and learn about how they work best for your particular use case. But that's basically it. Let's go ahead and open it up for questions. Let's see, how do we do that? Q&A, we have 2 questions. A question from someone, let's see, does the plugin support other formats besides GLTF? Yep, it does. So let's take a look again. Let's go in here. When you import files, you've got all these file options. So these all are supported, right? You can import all of these into Max. If you have a, say, an OBJ file, you can import that. You can import GLTF that you asked about, but you can also import the binary. And all these files are supported, which is super helpful. But you can also export to a ton of files too. So all these files are supported for export directly. Now you can use Max's default exporter, but the GLTF exporter that's directly in Max only supports certain things, right? We support all the different extensions. So if we pull up, for example, the help file, and we go to the reference docs and 3D processor, and here is format material support. And we show what we support for GLTF. We support all these extensions, which is really great if you have materials that are advanced in your file and you want to have, say, sheen for your fabrics and things, or transmission. All those things are supported in our importer and our exporter, and it's smart about that, which is nice. So that's that. Let's see. Then another question we had was, all options are also, oh yeah, so it wasn't a question. It was basically, how can we batch process multiple models in one go? So what happens in 3ds Max is it's really built for working on single option assets at a time so that you can go in and select different parts and perform different actions on different parts. That's really helpful when you have a super complex asset like this. And say you want to decimate these parts down to a lower ratio than, say, the other parts. You can just select assets, which asset you want to apply, and the actions are applied only to the selected objects. So that's what's super useful here, but it's not really meant for kind of a batch system. But what you can do is you can use the automation tooling, which we have available, so if we go to the main website here and look at 3D processor and how it works, you can start with the actions, and the actions work great inside of your asset, but you can dive deeper with these settings and actually run it either in the web platform, or you can run it in REST API. So you can call it the executable from within your own application and integrate it. And several partners have done that. And some of the biggest, I can't name names, but the biggest Hollywood studios you can think of use these tools, and like big 3D data companies that sell 3D models online, they use these things in the background. And then also CLI. So you can run with the CLI, this is an executable that you can run on your own local hardware on your machine and basically do all the processing locally on your own asset. And this is super great for batch optimizing tons of files together. So that's one way to do it, is a CLI. The other thing that we have is the web platform. And what's really cool here is you can upload assets to the web and actually use our hardware to process all that stuff. And you can set your own presets and apply those to your own assets. And that way you can batch process a whole bunch of assets in a really UI friendly way. It's a graphical user interface, so it's super helpful. So let's see what else. We did the formats, we did the batch optimization. What render, if any, is using to bake the AO? Yeah, so what's happening is it's using the RapidPipeline executable on the back end behind 3ds Max to actually bake the ambient occlusion. And you can choose, if you're not using the actions directly in Max, if you go, say, to the web platform, you can get really optimized with your settings. So let's pull up a RapidPipeline and take a look at that, just for quick. So here's the website. And if I go ahead and log in, what we've got here is all the assets here. And I can choose different assets, and I can run a 3D processor optimization preset on these. And these are all ones that I've customized myself and made with my own settings. But we've got all these kind of pre-created ones. And what you can do is go in and edit. So here's a bake ambient occlusion one. I can go in and edit this file and adjust the settings and choose exactly how I want to bake the ambient occlusion. So when I get down in here to my settings, I can go in and choose how strong to make the occlusion and how many samples to choose for the baking. There's a whole bunch of things about how many atlases to generate and what resolution. It's pretty awesome. There's tons of options and controls here too. Fine tune how you want to do your occlusion mapping. So that's the ambient occlusion. Let's see, the next question we had was, are there plans to bring this plugin to other programs like Maya or Blender? That's a good question. Yes, they're already in them, which is great. So let's take a look at that. So our integrations right now, we have Blender, we have Max, Maya, Unreal Engine, and Substance Painter. So all these tools are available in each one. I think Substance Painter is the unique one in that you can't really process your files directly inside, but what you can do is basically optimize the ways to bring in assets. So basically for Painter, it's basically a set of optimization routines to pull in models in the right format already. So set them up for painting and baking and that kind of thing. I think if we get in here, we can look at let's see. Oh, here we go, the import actions. So what they have for Substance is, hey, if I want to pull these in and generate new UVs for each part of my CAD asset, that's what you can do with the Painter one. And then all the other ones for Unreal and Maya and Max and Blender, you get all the full functionality. The cool thing about the Blender integration is you also have a pro mode. So you can actually do all the expert features in expert mode, which basically gives you all the options to do all the things that you can do in the web platform. So if you want to really get down into fine details and settings, you can do that in Blender, which is really cool. And it's directly integrated right in there. So that was that question. Let's see what else. Are there plans for a standalone version of the plugin? Yes. So standalone means basically that we're looking at making a kind of a desktop executable that runs on its own and basically is what this web platform is, but basically in a desktop form. And so that's underway, and we're talking about how to generate that right now. Does the scale of a scene influence the length of time for decimation? With architecture, we use some models that are hundreds of meters. Yeah, so that's a great question about scale. Does it really affect it? It doesn't, the scale doesn't really matter. I guess that it gets down to precision at that point. If your triangular format that you're going out to doesn't support precision out to, say, hundreds of meters out, that could be really difficult to handle. So I guess it depends on the precision. It isn't really a function of RapidPipeline's ability to do it. I think that's more of a restriction of the output format. The one thing about scale that matters, I think, are options that are relative to the scale of the model. For example, here, if we do, say, let's see, let's choose one that we know is based on things like a scale. So for example, if we want to clean up the mesh and merge vertices that are close together to each other, this is based on a distance in percentage relative to the overall bounding box of the whole model. So that is relative to the scale of the model. There are other things too. Remove small parts, for example. This is in scene units. So basically at 0.01, if the scene unit is 1 meter, then it's going to pull out anything that's smaller than 100th of a meter, which is a centimeter, right? Is that right? Yeah, a tenth of a meter is a decimeter. So if you want to say remove anything smaller than 1 centimeter, then that's what you can do. So those things are all relative to the scale of the scene, but we don't really have any limits in terms of how large the scene can get. Let's see what else. Is it supported for all versions of 3ds Max? Yeah, so it's supported for versions, I think, 2024, 2025, and 2026, and all the latest ones. So yeah, it really depends on, let's go look at it and see. I think, oh, it's 2025 or later. Yeah, it really requires the latest versions. We just created these integrations. They just came out and we announced them in August at SIGGRAPH in Vancouver. And so 2025 is the current version at that time, and that's what we developed it for. But contact us, let us know if you're interested in an earlier version. We can definitely talk, figure out something that's going to work for you. Because one great thing about DGG is that we're very responsive, and there are people behind all this, right? We don't use AI chatbots, we don't use AI things to shortcut things. We're people in the background, and you can ask us directly. Another cool thing here is that if you go to the chat function in the web, this goes to people. There's no AI person behind this chat messaging. So when you need support and you have a question about how something works, or even inside of Blender or inside of Max, you can ask us directly on the web in this crisp chat, and we'll answer you, which is really cool. And I think, let's see, we have any other questions here? How are we doing on time? We're at 10 o'clock. We've got another, 23 minutes or so. That's good. Okay, so the next question, does the import material need to be anything specific to be compatible on export? Yeah, that's a great question. When you're importing stuff using our importer, it automatically configures the material to be a physical material inside of 3ds Max. So that's just the initial support that we have. If I go into the material editor here and I get all my scene materials, yeah, it's 33 materials. It might take a little while. Let's select all these and make them smaller so we can see them, hide all the unused map slots. But basically, yeah, it's just using physical materials, which is super helpful. They're PBR materials, is what a physical material is. So it supports all the kind of PBR things that you're going to need for getting out to a web-ready format, something that works on export. In the future, we're looking at supporting OpenPBR, which has now great support inside of 3ds Max. So here's the OpenPBR material. That's something that we're actively working on right now and supporting. The whole industry is heading in this direction of using OpenPBR. But for right now, for the version 1 of the plugin, everything on import is converted into a physical material. And then what happens is on export, RapidPipeline automatically chooses the right kind of material based on the export format. So for example, OBJ has a very simple material model in a .mtl file, and it'll just export the channels that it can support for that. Or USDZ uses USD preview surface, which doesn't have things like transmission that you might get in GLTF or volume. We intelligently down convert that to the right material format. So transmission, which gives you clear reflective glass in GLTF, would just go out to alpha in a USDZ file. So hopefully that answered that question. Let's see, the next question is the plan currently to make Cinema 4D supported with the tool? And yes, so we do have plans to support other tools like C4D, and we've looked at other tools as well. I don't know what the full list is right now, but I know we've looked at various tools out there, and it depends on, do we have clients that really need those tools? And I think C4D is an obvious choice. One of the other things we've looked at is Keyshot, for example. Some of our clients have asked for Keyshot support. So we're looking at that as well. Yeah, it's really up to what our customers need and what they want. It seemed to us that Max, Maya, Blender, Unreal, and Substance Painter were the obvious targets because those are what the majority of people are out there are using for processing the 3D files. But it just makes sense to support more things when you have a core set of tools that works. This is really just a front end for the executable that runs on your local machine. It's fairly simple to go ahead and create a new front end as long as you understand the 3D tool behind it. And boy, I've been talking too much. My voice is starting to get hoarse. Let's see, did I cover all the questions? I'm looking through all the questions here. Standalone, we talked about different apps it supports. Customizing the baking, the AO. We talked about other formats besides GLTF, batch processing. I think we handled all of those. Let's see, what else? Any other questions out there? Let's see. That's all 9 questions answered. Another thing, I think I mentioned this earlier, but one thing that some of our clients have questions about are, does it support working locally on your machine? Like what's sent actually to the RapidPipeline server? And when you're working with the web platform here, which is super accessible, I don't need to use a 3D tool here. I can just import my assets directly, do a bunch of things, and I can also make embeds for this, which is really cool. So I can view on the web and share a link to this, and people can actually load this on their machine and see my models and how all their glory and whatever I did. And they can also see an AR, which is super helpful. But when you're using the web, of course, it's uploading the assets directly to our servers, and we're processing the file and basically paying for the hardware cost and all that and doing all that for you. But when you're using an integration like Blender or Maya or Max, that's running locally on your machine. And the only call that goes out to get this actually seat license that's used by the user. That's all it's doing. It's just sending out a ping to our web to say, hey, do you have an active license or not? And then it will basically use that. And then all the other processing is done locally on your machine, and none of this 3D data goes out. So let's see, we've got a few more questions, it looks like. Let me go ahead and look at the list here. Let's see, a question related to GLTF format. When using DCC importer to convert materials, for instance, from V-Ray to physical materials, will the resulting GLTF store any tiling values? Yeah. So DCC importer is a separate tool that we have. Let's go to the website here and talk about that a little bit. So DCC importer, we've worked closely on that. Where is it here? It is in the reference docs. Here it is. DCC importer, what's cool here is that this is a tool we developed in partner with some of our biggest clients to basically take their models that are in Max with V-Ray materials and automatically down convert those into something that works in a web-ready format. And so basically what's happening here is DCC Importers is examining all of the nodes inside of your V-Ray material and figuring out what it can preserve as tiling and what it has to bake as an atlas. So for example, let's go look at guidelines. This has some great stuff about tiling. And what happens here is that when we examine the material tree, if it's just using solid values like no textures, that's just exported directly. We don't have to do any baking. It's really simple to convert that over to something that works in GLTF. When a texture is tiling, we can preserve that tiling in the output as long as you're not mixing together, say, two textures that use different tiling values. Then there's no way we can support that in a single texture when it goes out to GLTF. That has to be baked. So for example, this one uses sheen, and that gets exported properly to GLTF sheen. But this uses, say, this gold texture is tiled a certain amount, and then there's a fabric texture that's tiled a different amount. Well, how do you represent those in a single bitmap without baking it down? So at that point, it bakes to an atlas. But if you're using tile textures like this, only tiled, and all the tile textures share the same tiling amounts, so say the normal map's tiled and the diffuse texture and the roughness texture, and they're all tiled 5 times or whatever it is, that all gets preserved, and we just export the existing textures as they are, and the tiling values go into, I think it's the texture transform extension. Yeah, here we talked about the UVs a little bit, right? That's what an atlas looks like. And this is commonly what tiled texture UVs look like. So it'll preserve those UVs and not create an atlas, unless you go ahead and say, hey, I want to have an ambient occlusion texture now. So what it'll do in that case is it'll preserve the tiling for the tile textures, and it'll create a second UV and use that for the ambient occlusion bake. And that's all automatic. So it just does that for you. It's just smart about that. And you can go through, maybe we can post a link to this in the chat, but that's how it explains all the stuff that's exported in the DCC importer. Let's see, does RapidPipeline generate UVs? Do the objects need to have proper UVs to bake AO? Yeah, so that's a great question. We do generate UVs. As I said before, if your model has tiled UVs and you're not baking an AO, then it just keeps those UVs as they are. But if you say, I want to bake an ambient occlusion texture, so for example, in here, I have bake occlusion map on, that's going to need a second UV set. And so it says it, if you can see the tooltip, it's tiny, but the tooltip says basically, yes, it will bake to a second UV set. Or if the whole model has just one UV, then it will just bake into that atlas instead. So for example, this thing, I know I baked it out and I said, go ahead and merge it all into one single atlas. And so it generated an atlas. This didn't have UVs to start. The other thing that we support too is we support the ability to, and this is actually an older version of the plugin. We have a new action that will generate box mapped UVs, or a triplanar mapping, as it's also called. And so you can generate triplanar UVs for your models. So for example, the Substance plugin has an action for automatically generating tiled UVs. And so what it does is, it's not really paintable, right? But it's great if you have a bunch of materials and you have tiled texture materials, you can automatically assign those. And it chooses the scale. You can choose the scale of the kind of projection. So by default, it creates a box that's 1 meter and then maps it from the 3 different sides. But you can do real world scale UVs just by adjusting this UV scale parameter. So for example, if you wanted to do 1-inch UVs, which is common for e-commerce workflows like this chair, then you just set the scale value to how many inches are in meters, right? It's 0.254 is the scale of an inch to 1 meter. And then that makes the UVs scaled at that scale. And that's how that works. Let's see. I think that's all the questions. We've got 10 minutes left. What else can we talk about? We can look more at what's in 3ds Max. Let's do that. Let's make another scene here. Let's open the blank scene again. So we have our nice PBR lighting. And what's happening here in this blank scene is I've got this environment, and it's one of the ones that comes with it. And I've just set it to use a custom background so it's not distracting. If we turn that off, we can see what the scene is. It's just this Victorian parlor. But what's useful here is if we import another file, for example, let's pull in this guy. This is a great scene. And it's a GLB file. I don't think I need to do anything here. I'm just going to import it direct. And what it is, it's a statue that somebody's captured with photogrammetry. And it's a great kind of sample file because it's got a ton of triangles, right? There's a lot of detail, but it's this photogrammetry thing. Beautiful kind of sculpture, actually. But it's made of 19 different parts, right? And so that's a lot of separate pieces. And there's a lot of detail here that you probably want to bake down and make into a simpler asset so that it's a much smaller file. If we look at the original file, it's 65 megs. Oh my God, that's huge. Let's take a look at it in GLTF report and see how big those textures are. Let me pull it in. It's 65 meg file. Let's see. It's got one 4K texture. So the texture really isn't the problem, although it is a PNG file, which makes it pretty big. But it's just the problem is it's got way too many parts and way too many triangles. And so it's a pretty inefficient file as far as web viewing goes. It just takes too long for people to download. So one thing you do is pull in the RapidPipeline toolset, and we can just decimate it directly. You can either decimate and bake, or you can decimate directly without baking. And what happens here is generally what I want to do is with this kind of asset is I want to collapse it all down to a single entity instead of 19 entities, just because it's going to weld all the seams between these different photogrammetry patches. You can see here, that's going to create problems when you try to decimate down. It might create gaps between those because the poly counts are going to be different, right? So it's better to use something like one of these to actually decimate this down and make it a single asset. I'm just going to make it say, let's choose a low target, say 10K, something that's really low. Let's go even 5K. Let's go really low. Another thing that's cool to talk about is the deviation percentage. So deviation is really cool. If you choose a face target, you can say, I just want 5,000 triangles, that's it. But deviation percentage will look at the surface curvature of the object and try to figure out, that's my maximum value. But how can I how can I remove detail from flat areas more than from curved areas and actually preserve the overall curvature of the object so that the silhouette stays the same? And basically what this is a precision value. I can say, I want to be even more aggressive and go really aggressive with the decimation, still try to preserve the curvature, but get a lot lower than 5,000. It's going to try to do that. So let's just do this and let's say, go ahead and collapse it all and merge it all down and run it. And now it should merge it all down to one single node and get us down under 5,000. It's probably going to even go a lot lower because of the deviation. Let's take a look and see what happens. And it's all baking it down to one bake because it's got to create new UVs when it collapses all these down into one object. So it's running in the background. What else? I haven't really tested this out, so who knows what's going to happen here. Oh, there it goes. So it has decimated it down and done actually an amazing job of preserving all the original detail of the model and all the curvature, but we've gotten down to 5,000 triangles. I think the deviation target didn't really do much because there aren't really that many flat surfaces here. Even the base has a lot of kind of fine curvature to it. It's not totally flat, but damn, 5,000 tries, that's super tiny. Let's export this and see what we get. I think I'll choose GLB again, just because it's easy to get a web viewer for that. I think for USDZ, I haven't seen that many. I'm not gonna go ahead and, yeah, just the defaults. There it goes, it's out. Let's pull it in. Here's our lion file. Now it's down to 9K. I think because the texture is a 4K texture. That's why that's probably the largest part of the file now. So yeah, there it is. Let's see. Yeah, so because we had baking on, it baked out a normal map as well, which is probably why it looks so great, because it's captured a ton of detail in the actual neural map, which is going to help a lot with getting down to 5K triangles. So if we pull it into the sample viewer, we can look at the individual channels and see what's going on. Let's see the normal texture. Oh yes, there's a ton of detail here, right? It's capturing all that fine detail and using it in the surface. If we open up, say, Babylon, for example, we can actually turn off the normal map and see how it looks without the normal map, right? So here it is. Here's the material. And if we turn off the bump, yeah. So wow, what a difference, right? It really shows the low poly nature without that normal map. But with the normal map, you get all that fine detail back again. That ones probably makes more sense. So that's a cool thing, right? Yeah, I got down to 5K, but I still see all the muscle detail and stuff going on there. That's pretty cool. Let's make sure I got all my questions answered. I think that's basically it, right? I think we're almost at time. So anyway, that was basically it. That's 3ds Max and how to, use RapidPipeline directly inside of Max. And it's super interactive and super easy to use. And yeah, it preserves all the original meshes, which is really cool too. So I can always go back and redo with different settings. Anyway, I wanted to thank you all for joining us today. Let's see, stop my share so you can see me. Again, thanks so much for coming, and reach out, let us know how we did. And if you have any further questions, I'm always happy to help out.